This is New York Chem Coach with the June 2015 New York State Chemistry Regents Exam, questions 36 through 39. Pause the video, answer the questions, and then come back and we'll go over the answers and explanations. Here are the answers. Okay, let's take a look. We're looking for the element that would fit the formula XCl4. Well, you can do this by process of elimination, or you can also just look up and pretty much know it's number 1 right away once you take a look at the periodic table. We're talking about carbon, hydrogen as a possibility, magnesium, and of course I forgot, it's zinc. Alright, here we go. So we have these 4 different elements bonding with chlorine. Chlorine typically wants to gain an electron. Certainly when it's with a metal, zinc or magnesium, we're going to get zinc chloride, ZnCl2, because the charges, zinc would be +2, chlorine -1. We'd have to even out electrons lost and electrons gained. Same thing with magnesium. Magnesium chloride would be MgCl2. Magnesium's +2, chlorine's -1. To balance out electrons lost and gained, it would be MgCl2. Hydrogen with chlorine. Hydrogen's +1, chlorine's a -1. It would just be HCl. So already by process of elimination, carbon's the answer. But let's take a look at it a little bit further. Carbon has 4 valence electrons. Chlorine needs 1. So it turns out that when carbon bonds with chlorine, we're going to end up with 4 chlorine atoms because the 4 electrons that carbon has plus 4 more from each of the 4 chlorines is going to give carbon that stable octet, just like chlorine feeling it has a stable octet. So we end up with CCl4. Let's take a look at question 37. We're dealing with a formula, C2H4. All we're getting are the different elements and the number of times it's appearing in the formula. So this is a molecular formula only. A structural formula is when we have the layout of the atoms with the bonds. And in fact, this would be ethene, and it would look like this. So a structural formula gives you a layout, much more information. An empirical formula, that's the lowest whole number ratio. And for C2H4, I can reduce the numbers and divide by 2 and end up with what's called an empirical formula of CH2. So that's why the answer is choice 2. Let's go to 38. For 38, we're dealing with what's called a mole-mole problem, also known as stoichiometry. And what we have to remember is when we have balanced equations, we're looking at what's called a whole number ratio. So my suggestion is you put information above the equation, and then we're going to put information below. So how many moles of aluminum? So here's my X, right here. React completely with 4.5 moles of oxygen to produce 3 moles of aluminum oxide. Well, they gave us a little bit more information that we need, so we can work with the 4.5 for the oxygen, or we could actually even work with the 3 for the aluminum oxide. But let's just work with the aluminum and the oxygen. So I have X and I have 4.5. What I'm putting below the balanced equation is the coefficient of 4 and the coefficient of 3. Because that's the ratio. So what do I have? I really have just a proportion. I have X over 4 is equal to 4.5 over 3. So I'm going to go ahead and I'm going to cross multiply and then divide. I have 3x is equal to 4 times 4.5 is 18. Now I have to divide by 3 on both sides, and of course 18 divided by 3 is 6, so my answer is 6. Now, would it have worked exactly the same way if I used the aluminum to the aluminum oxide? The answer is absolutely. The way that this is worded, it's going to take 6 moles of aluminum, 4.5 of oxygen to make 3 moles of aluminum oxide. So I could use either or. So they're trying to trick you by giving you more information. Don't take the trick. Finally, for 39, we're looking for the percent composition by mass of oxygen in calcium, that's nitrate. So what do I have to do for something like this? Well, I'm dealing with a percent. So a percent always means a part over a whole thing times 100. And in fact, if we go to the formula and equation sheet from the reference tables, we see percent here. Okay, there are 2 different percents that are on the table, percent error and percent composition by mass. We want percent composition by mass. Okay, we don't have a measured value and accepted, so you have to use the words here and make sure you know which one you're looking at. So let's take a look. Now, the thing that's tricky here is, of course, you're looking for the oxygen. Remember, for calcium nitrate, they already give you the gram formula mass. Okay, the mass is 164 grams for every mole of this. But I need now, that's going to be the whole thing. That's the 164. I'm going to multiply by 100, and I'm going to get a percent. But now I need for the oxygen. Now, I'm not going to just take 3 and multiply it by the gram formula mass of oxygen, which is here. Let me put it in a different color. Here, which is essentially 16. Right? I have to distribute the 2 inside of the parentheses because it means 2 nitrates, and 3 times 2 is 6. So I need to take the 16, which is the gram formula mass for oxygen, and I got to multiply it not by 3, but by 6. And that's 96. And if you're a little clicking, that's me with my calculator, because don't do this without a calculator. Don't do this without the reference tables. 96 divided by 164, and then times 100 is essentially 58.5 or 59%. There's my answer. These are not hard questions, but if you don't use a calculator for things like questions 38 and 39, it's easy to make a mistake. This is New York Chem Coach. Hit the like button below from the video and check out more videos on NewYorkChemCoach.com.